So it's usually about this time I introduce the easier way to do this. And you're probably thinking, why didn't you show me the easiest way in the first place? Because then you wouldn't have understood. I don't know if that's true or not, but this is just the way we do it. Yeah, like, Dr. K, is there an easy way? And then I wait till the very end to show you. Yeah, it's not very nice. I'm sorry. But anyways, here it goes. You can get all these electron configurations based on the periodic table. Okay, so I'm going to go back up a couple of pages. We're on page 8 now. And I'm going to show you, like, where these different orbitals are on the periodic table. Okay, so you have my little footnote down here, right? It says S is 2, P is 6, D is 10, as F is 14, that kind of thing. So this is just a sketch of a periodic table I made in Excel or Word. I can't even remember exactly where I made it. But this is energy level 1, right? And this is energy level 2. Oh, sorry. This is 1, 2, 3, 4, 5, 6, and this is 7. That's the newest row. All these down here are brand new elements, more or less. And these are the inner transitions, and they actually fit like right in here, okay? So, but I'm not going to worry about that for now. What I want to do is first focus on, there's, of the S orbitals, you can get 2 electrons of the S type, right? So you'll notice that this is up here, 2 columns wide. And anything that's in this row is going to have its end of its electron configuration, or in this row, in this column, it's going to have the end of its electron configuration as S1. Now, and then I'll do examples based off this periodic table position, right? This is the second column, and you're adding 1 more electron. Think about it. If you're here, you have 3 electrons, and here you have 4 electrons. Well, this is going to be S2 like that. Now, what about, for example, if I do the p orbitals, right? We said p orbitals have 6. Where do you have 6 columns, right? Take a look at your periodic table. Where do you find 6 columns? Because it's a key to understanding like why this works. And the answer is over here on the right. This would, and these all end as P1. These are P2, P3, P4, P5, and except for helium, because helium actually in old periodic tables was next to hydrogen. It was actually in both places. So this is actually going to end in P6, except for helium, which ends in S2. Okay, so these are all P6s. So then you got to say to yourself, well, where are the D's at, right? Because D's are 10, right? So where do you see 10, right? So this is 10 wide. If you count it, I'm using my finger. 1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is actually D1, D2, D3, D4, D5, D6, D7, D8, D9, and D10. Now you don't have to remember like which column it is. You can just count it out every time, right? And there's F's, right? Well, and I should say, I'll just say this now. This is this group that I'm going to do in, I don't know, turquoise. I don't know, it's not turquoise. I used to tease my daughter. It used to be her favorite color. We call it turquoise. Yeah, so anyways, this is the S block. Let me do it. Just do it like this. I won't draw a line like that. Just do that. This is the P block. Usually a hyphen in there, sorry. And then my highlighter I used was this one. And then the D block is these guys here. I'm not very good at coloring in the lines, sorry. So this is the D block. Like that. And the F block, I'm just not going to highlight it. These are down here. This is the F block down here. because F block should be 14, right? So 1, do it with this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's kind of pretty cool to me. It always has been really cool to me that when we're looking at this periodic table, right, it's got all this quantum mechanics stuff all built into it. Like we thought, we think we're so clever, we figured out quantum mechanics, but it was just sitting there staring at us for 100 years roughly. I guess not the whole periodic table. But it was staring at us for a long time and trying to tell us stuff, and we just didn't understand. So there's a lot in science that's that way, which is kind of fun because there's a lot of stuff that people can still do. All right. And maybe we never really ever know, right? So how am I going to do? So here's the thing you got to remember. I want to make this useful. So remember we did iron, right? And if you know where iron is on the periodic table, it's here. Like that. And I need to do its electron configuration. I know it ends in D6, and here's the other thing you know, because it's ground state, right? Everything else before it's full. Now, I'm going to do this with core notation because it's way easier. The only element I need to know besides the iron is I need to know this one here, and this is argon. So that means my core, if I'm doing the electron configuration for iron, I'm going to go like this. I'm going to say argon. Right now, after argon, I'm in the S block, and then I'm in the D block. So this is energy level 4, so it's going to be 4, or it's like period 4, right? 4s2. I know it's full, and then the partially full will be the D, so it'll be 3d6. And the important part about this, that it's 3d6, these are always what we say n-1 for the principal quantum number. So if you're in 5, the d orbitals are 4. If you're in 4, the d orbitals are 3, right? These are actually n-2. So when you're doing these, you're going to be 2 energy levels down. So when you're down here and you're inserting right here, this is 6 minus 2, so these are actually the 4f's, and these are the 5f's down in here. So they're 2 less than the period that they insert at. And then for the P block, right, this is just the same. So it's 2s and 2p, for example. So let's say we're going to do sulfur. So again, if you know where sulfur is on the periodic table, it's right here, right? And we want to do the electron configuration, and we're going to use core notation. Okay, so we'll use core notation for it. Then I have to go like this. What's this element here? It's the only noble gas. So let me do it in different colors so it shows up. Is this going to erase the S, or is it going to erase? Oh, it erases everything. Great. Let me color that back in. I'll try. I didn't stay with. I'll try to stay in the lines, but I didn't do much better. All right. So I'm going to do sulfur. That's here. I was going to do it in a different color. Nice. So we'll do S, and then this is neon over here. That's the only 2 things you need to know, right? So then you're going to write it like this. You're going to say the core for this one here is for iron, but for sulfur, write it down here. I'll say it's the core is neon like this, and then it's in the 3rd period. So I know this is P4, but it's 3P4, right? And then I know 3s is full, so I can just write 3s, 2 because it can hold 2, and then I can write 3p, 4. Again, if I didn't have the numbers up here, right, I would just go like this. 1, 2, 3, 4. It's 3p4. Okay. So having the numbers up here is nice. But most people don't have the numbers up here and they just count. Okay. Again, you can do any element on the periodic table this way using core notation for sure. It's real easy. Even if you wanted to do one way down here, like this would be whatever element that is, right? I don't even know I do know off the top of my head, but pretend I didn't know off the top of my head what it was. I could still do the electron configuration. I could go this element, right, is D10, so I know it ends in D10. Let's do it in a different color. In fuchsia. I know that neon, and then I have argon, and then I have krypton like this, right? I think that's right. Anyways, and then I'm going to go core, Kr, and then 5s2, and then it's one less, so it's 4d10, like that. Okay, and then you look it up, and it's cadmium. Right? You can look up from that electron configuration. It's cadmium down in here. Okay, so here's an opportunity for you to practice what I just taught you about being able to do the electron configurations from the periodic table. And what I've done is I've drawn a sort of simplified periodic table at the bottom here, so you can see where each of the elements are. And without actually referring back to a periodic table, see if you can do the electron configuration. So I guess I should put here that this is helium, and then neon, and then argon, and then krypton, and that's the last one you know. This is xenon down here, but it's not important because it's past the element. So we'll go ahead and try to do magnesium that way. All right, so what I'm going to do is this. And what you should do is pause the video, try to do magnesium, and then I'll come back and I'll have filled in some information so that you can do magnesium, and then we'll do the same thing. We'll pause and we'll do iodine, and then we'll do cobalt-3 ion. Okay, so we'll do that one at a time though. All right, so hopefully you got that. I just counted the number of rows or periods down that magnesium was on, and I saw that it ended at the on energy level 3, or principal quantum number 3. So, and it's in the S block, so I know it ends as 3s, and because it's in the second column, like I go 1 and 2, that is 3s2. The core is neon. It's the noble gas that's right before the magnesium. Okay, so let's go ahead and try to do iodine next. We'll just take them in order. Okay, so this is what you should have been able to do, is fill in for 4 and 5, because iodine, if I got my eyes were lined up right, yeah, it's on this 5th period, right? And then it's going to end as 5p5, because it's in the 1, 2, 3, 4, 5th column over. And then I'm going to fill in, right, 5s2, 4d10, and then the part I said, the 5p5, so that's the configuration from the periodic table. Now here's the trick with cobalt, right? For cobalt, it's a 3+, so this actually represents CO3+. What you kind of need to do when you do cobalt 3+ is do cobalt and then take 3 electrons off. You'll take the S's first, and then anything else has to come off the D. Okay, so we'll leave it as that. I'll let you go ahead and do the cobalt 3+ ion. Again, I'll pause it, I'll draw a cobalt, and then we'll do the cobalt 3+ together. Okay. Okay, so hopefully you got to the point where you got cobalt as the core is argon, because it's on the 4th period, so at the end of the 3rd period, right, that's where argon is. It's the one before cobalt. And then because it ends here, I know it's 3D, right? But then I go 1, 2, 3, 4, 5, 6. You already see the dot where I counted 7. So it's 3d7 that it ends in, and then it's 4s2 beforehand. So 4s2, 3d7. So now we have to do the 3+ ion, right? And what we're going to do is we're going to get rid of this electron, these 2 electrons, but that only gives us 2+, right? So we need to get 3+, so the last one has to come off the 3d, and so the electron configuration is argon for, I keep doing that, 3d 6, like that. Okay, so what we'll cover in the next segment is to talk about orbital diagrams and how we get orbital diagrams from the electron configurations.